कोवेरिएंट या हम कह लें कॉम्पैक्ट या हम कहें रिड्यूस्ड, इसका फॉर्म ऑफ डिरैक इक्वेशन। डिरैक इक्वेशन तो इसकी शुरुआत होती है बेसिक डिरैक रिलेटिविस्टिक इक्वेशन से उठाएंगे। वी नो दैट एच साई इज इक्वल टू ई साई। So in case of Dirac, we know that E minus C alpha P beta m naught C square psi is equal to 0। और इसी को आप लिख सकते हैं, एनर्जी का हमने ऑपरेटर फॉर्म में लिखा, तो दैट इज आई एच कट करली और करली टी प्लस आइटा एच कट मोमेंटम ऑपरेटर हमने लिखा, तो इसके लिए हमने सी अल्फा डेल देन बीटा एम नॉट सी स्क्वायर साई इज इक्वल टू 0। अब ये जो आपकी डिरैक इक्वेशन है, इस डिरैक इक्वेशन से हमने शुरुआत करनी है। इसी डिरैक इक्वेशन को हम दूसरे तरीके से लिख सकते हैं। नेगेटिव कॉमन लेने के बाद हम इसको कैसे लिखेंगे, एच कट करली और करली टी माइनस आई एच कट सी अल्फा डेल, then this will become positive beta m naught c square psi is equal to 0। इसी को थोड़ा एक स्टेप हम बढ़ा लेते हैं, इसको हम इंडिविजुअल psi को हम क्या अंदर लेके जा सकते हैं, तो कैसे लिखेंगे, और आई एट कट देन करली ओवर इस करली साई और करली टी माइनस आइटा एच कट सी अल्फा, and if we take the subscript as analyzed, then this you can take this as an alpha k, and similarly to delta we can write down curly psi by curly xk, then is your beta m naught c square psi is equal to 0। This is your equation number 1. Now in case of the Dirac equation, when we find out that Dirac equation, and at that time we know that in 4 vector form we can write क्या लेते थे वहां पे x y z और t, and we can write down this as xk x4 in that article. Previously we have done this one, so we know that k will change from 1 to 3 and your x4 will be time coordinate, and this is known as your, this x4 is nothing but it is Minkowski space coordinate. So this is very important one. You can write down this one as Minkowski space coordinate. Now combinedly you can also write down is 2, as you already know this one, x mu, where your mu changes from 1 to 4. So this little assumption we have done in case of that the Dirac equation. Now what we will do here, we will multiply this equation number 1 by a factor beta by c. Multiply equation 1 by beta by c. और मल्टीप्लीकेशन करने के लिए हमने फ्रॉम लेफ्ट साइड कहे या प्री मल्टीप्लीकेशन कहे लेफ्ट, and we will get, then multiply this by beta by c. So what we will get, it will be simply iota h cut beta c curly psi over curly t iota h cut beta alpha k curly psi over curly xk plus beta square m naught c psi is equal to 0. Now we know that beta square, we already know that previously we had done this, that beta square is equal to 1. So what we will get here, then this equation will become, you can write down this as, now that is beta curly psi over curly iota ct. Now what we have done here, we have just combined this iota, or what you can write down, just multiply this by iota and divide by iota. So iota will cancel out, so there will be no change. But here iota square, and this will become iota square, and this will be equal to -1, and minus will become positive. So here positive will come. So simply what we can write down here is, in short, we can write down that beta curly psi by curly t and iota ct, and then next plus minus iota h cut. Now one more thing we can do here is, or you just simply we forget h cut here, that iota h cut beta alpha k curly psi over curly xk, then m naught c by h cut, not, it will not h cut, here h cut psi is equal to 0. One more thing you can do, you just divide it by h cut. So here h cut, and this is h cut. So what we will get here is beta curly psi over curly ict plus minus iota beta alpha k curly psi by curly xk, and then plus m naught c by h cut psi is equal to 0. Now this is equation number 2. Now here we will try to introduce the gamma matrices. So we just define, so what we can now, we will now introduce gamma matrices defined as, so here gamma 4 will be equal to, let me introduce gamma 4 is equal to beta. So this is first assumption. Then here beta we have taken as 1 0 0 1, 1 0 0 1, and this is -1, not 1. So what we will get, and for then your and gamma k, because we have taken gamma 4. Now gamma k is equal to iota, beta, alpha k. We have taken this one as gamma k, and we will put all the value of beta and alpha k. We have done this. We have already assumed this one in the Dirac equation. So we know that minus iota, what is beta? You just try to put here 1, 0, minus 1. This next. Now we know that the alpha k. What was alpha k there? Alpha k were purely spin matrices, and they were sigma k, and when we will multiply this, we will get 0 minus iota sigma k 0. And in this case, what is k here? K is 1, 2, 3. So combinedly, this is your equation number 3. Now you just take this one, ICT. Now this ICT you will consider as x4. What is this? That is x4. That is your ICT, and it is very, very important. This is known as Minkowski space coordinate. Why we will call it space? ये बिल्कुल आसान है. देखिए, what is this? This is your velocity, this is your time. So the product of velocity and time क्या होता है आपके पास? Distance. क्या होता है? Distance. So इसको हम लिख सकते हैं x. यानी कि इसलिए हमने इसको क्या कहा? Minkowski space coordinate. Very, very important. अब हमारे पास इक्वेशन नंबर 2 है. अब इक्वेशन नंबर 2 से now we'll take equation number 2. What we will get, that is from equation 2. Now put all these values into equation number 2, and equation 2 will becomes beta curly psi by curly x4 plus gamma k curly psi by curly xk plus m naught c h cut curly psi is equal to 0. Now we know that this beta is equal to gamma 4. So we have taken gamma 4 curly psi by curly x4 and gamma k curly psi by curly xk plus m naught c by h cut curly, this is your psi, equal to 0. Now we can reduce it further because we know this. What is this? Reduce from 4 compact. Further we can reduce it as, let here is 4, it is up to 1, 2, 3. So we will come on, if we take any other subscript, that mu is gamma mu, that is curly psi curly x, similarly x mu plus m naught c h cut, because we have reduced these terms into single one, this one, because this k was varying from 1 to 3 and it is 4. So we take another, that is mu, which vary from 1 to 4. So means Now we have reduced these two terms into single one by replacing this k and 4 with a mu, and where mu changes from 1 to 4. So the third term will be the same, psi is equal to 0. This is your reduced form, where x mu is equal to, what is this? You can write down your x mu. In x mu, you write down it as sk x naught, or where mu changes from 1 to 4. And this is known as your, or you can say that, required covariant, yeah, compact, yeah, reduced form. This is article.